Mobile Application Testing. Chapter 1. Mobile Application Architecture. There are multiple solutions to designing a mobile application. Some of the considerations in choosing a particular architecture or design decision include target audience, type of application, support of various mobile and non-mobile platforms, connectivity needs, data storage needs, connections to other devices including IoT appliances. Architectural decisions include client-side architecture such as thin or fat client, server-side architecture such as single or multi-tier, connection types such as Wi-Fi, cellular data, near-field communication, NFC, Bluetooth, data synchronization methods such as store and forward, push and pull, synchronous, and asynchronous communications. Client-side versus server-side architectures. Thin client apps do not contain application code, which is customized to the device and make minimal use of mobile operating system features. These apps typically use the web browser as the front end, and JavaScript as the language for implementing client-side logic. Thick client and server architecture insights. Thick/fat client applications may have multiple layers of application code and may use mobile operating system features. These are typically native or hybrid applications. Single-tier architectures are monolithic and have all servers on the same machine. They are less scalable and harder to secure. Multi-tier architectures spread server-side components across various units. Two-tier architectures involve separate web and database servers, whereas three-tier architectures also include an application server. Multi-tier architectures allow separation of responsibilities, provide database specialization, and provide better flexibility, scalability, and security. However, they may be significantly more expensive to develop, manage, and host compared to single-tier architectures. Connection types and app connectivity modes. A mobile device might be connected to the server via connection types such as Wi-Fi or via cellular data connections such as 2G, 3G, 4G, and 5G. Mobile applications typically operate in one of the following three modes. Always connected apps require a permanent network connection during operation. All mobile web applications fall into this category, although some can operate in a limited way. When partially connected apps require a connection for tasks such as data transfer, but can operate for long periods of time without connection. Never connected apps work offline and don't need to be connected. A simple calculator is an example of such an app. Data synchronization modes. The synchronization of data between the client and the server can be conducted in the following modes. Continuous mode is where the data gets transferred as soon as it is submitted. Store and forward mode is where the data may be stored locally before being transferred, especially when no connectivity is available. Synchronous versus asynchronous data transfer. The data transfer can be performed in the following two approaches. Synchronous data transfer is performed when the calling function waits for the called function to complete before returning. Asynchronous data transfer is performed when the called server function returns immediately, processes the data in the background, and calls back the calling client function once it completes the task. This gives users more control. However, implementing the handshake mechanism increases complexity concerning the availability of the client or the network when the server initiates the callback.